PID was invented in 1911 for the US Navy and was finally implemented in the late 30s and early 40s as a pneumatic type control. But what is PID? So PID is just a way to control something. And I think it's fair to say most people, it's kind of a mystery to them or they don't understand it fully. But it's just simply a way to control something. PID, P stands for proportional, I stands for integral, and D stands for derivative. So let me kind of illustrate what PID is and how it works with an example I think most people would understand. So imagine you're driving your favorite classic car. All right, down the road, I'm gonna be driving a 1964 Pontiac GTO. All right, you're coming up on a curve. And what you're trying to do is stay in the middle of your lane, right? So you're coming up on the curve and you start to enter the curve and you see, oh, I'm not really in the middle of my lane anymore because the curve is starting, right? So the difference between being in the middle of the lane and where you are, that's called the error, okay? So the PID of control loop acts upon the error, proportionally, integrally, and derivatively. It's not really a word. So imagine this. So you're driving, you see that you're not in the middle, that's your error, so you correct the steering wheel a little bit, right, to try to bring you back into the center. Okay, that's called the proportional aspect of the control. Okay, so your brain has just made a proportional change. All right, so now you continue to go on the curve and you see that, oh, I'm still not quite following it. So over time, I've kind of strayed away from the center now, again, at the curve. So now you start to adjust again. That's the integral part of it. So that's the error over time. All right, but when you did that, you kind of hit a slippery spot. So now the back of the car is starting to skid around on you. And what do they always tell you? Turn into the skid, right? Well, so the rate of change is how fast the car is starting to rotate because of the skid. All right, so you correct for that. That's the derivative part of the control. So those three things acting together work to control you, or you work to control yourself in the middle of the lane on a curve. So that's proportional, integral, and derivative control. So why do we care about that? Well, so in the example of, say, an ESP controller, PID control is typically used with I limit. I think everyone is kind of familiar with I limit, current limit, I limit. And so the PID control is used to control the current going to the motor. And that may be kind of transparent to a lot of the operators. It's built in. With our Smartin, you can enable it. So you can go in and turn it on if you want, and then you can tune it. And we can talk about the tuning a little bit later if you want. So there's other things that you might use it for in a ESP controller. If you have one available to use, you could use it to control your casing pressure or your tubing pressure or maybe a flow rate or something like that. So that would be a typical use for it. And then the other mystifying part is trying to tune a loop. So PID, each of those things have what's called a gain associated with it. And that's how much you act upon each of those three things, right? So let me just tell you a secret, which is most of the time, don't use the D part. You don't need it. Just use the P and the I, because the D is just gonna mess you up. The D does what's called noise amplification. So if there's noise in the signal, the D is gonna make it worse. So for most things, just ignore the D. Might use it for temperature control, but that's probably about it.